Alright, let's get started with this one. Let's just review what we've been doing, solving right triangles using a picture, before we jump into some word problems. Alright, so again, what we do is we assess what we have. We're looking for the angle. We've got the side across from it, and we've got the hypotenuse. So again, the best trig function to use here would be the sine, opposite over hypotenuse. So the sine of x is going to equal 22.5 meters divided by 39.9 meters. So as you notice with triangles, trig relationships deal with angles and side lengths, and that's all. So we need our handy dandy calculator, and we do 22.5 divided by 39.9. And that gives us a very long decimal, which we do second sign, second answer, because it'll put that in for us unless you just want to type it in. I don't, because I always make mistakes. And that'll give me my angle, which is 34.3 degrees. And that's all that there is to it. Not too bad, I hope. Let's look at a word problem or two. This one's fun. A high wire artist ascends to a platform by walking 195 feet on an inclined wire that makes an angle of 33 degrees with the floor. How far above the ground is the platform? Oh my goodness. The key to this problem is knowing exactly what it's asking you. Alright, so first of all, what we have here is we've got the floor, and we've got this platform that's kind of high up. Well, it's sort of high up, I guess. We'll call that the platform. In fact, I'm going to make it really thick so it's just really obvious that this is the platform. It's connected to some wall somewhere. That is our platform. Kind of like a swimming platform that you jump on to jump into the water. Anyway, this is a high wire artist, so he's coming from the floor and he's trying to be all dramatic, and he's going to walk up the wire. Kind of like that guy that walked across the Grand Canyon on that thin wire. I forget his name, but anyhow, he did that. Now what we know about this is that the high wire artist ascends. So this is our high wire artist right here, and he is ascending by walking. He's walking up this high wire to the platform. This is my platform. So most of the word problems is just taking the time to keep reading the problem over and over again, trying to figure out what is it asking me to do. So that's our platform, and he's walking 195 feet. So from here to here is 195 feet. And that's from here to there. And the angle is 33 degrees with the floor. So this wire makes a 33-degree angles with the floor, and this is the floor, which he does not want to hit as he ascends to that platform. And what are we trying to figure out? How far above the ground or the floor is the platform? Well, we want to know the height of this triangle, which you could use as h if you like, but it's just a simple, once you draw the triangle, and Lord knows make it look like a triangle, mine doesn't. You're looking for x. This angle is 33, and this side is 195. So let's go for it. Again, we look at what we've got and we decide what is the best trig function to use. Looks like it's going to be the sine again, opposite over hypotenuse. So you do the sine of 33 degrees is equal to the opposite side, x, over the hypotenuse, 195. And now to solve this problem, you can put a 1 underneath here and cross multiply. I'll go ahead and do that. I've never done that one before. And when you multiply, you get x times 1, which is x, and 195 times the sine of 33. And at this point, we take out our handy dandy calculator, making sure it's in degree mode, of course, and we multiply it through. And we will have the height of our platform. Now our platform is not going to be bigger than 195 because again this is a right triangle and the hypotenuse is the longest side. So what we've got here is 195 times the sine of 33. 195 times the sine of 33 is 106.2. So this platform is 106.2 feet above the ground, and that's really high. I don't want to walk that. But to each his own. Alright, let's look at another word problem. The measure of the base angle of an isosceles triangle is 37 degrees, and the length of the base is 14 feet. Find the height of the triangle. Okay, so the key to this is knowing some stuff about an isosceles triangle. First of all, you need to know that these sides right here are called the legs, and this side is the base. So that means that this whole side right here is 14, because it's the base. And we know that the base angles, which are the angles that sit on the base, are the ones that are equal to each other. So this angle and this angle are both 37 degrees. I'll put it right there, 37 degrees. I'll put it right there, 37 degrees. The base angles of an isosceles triangle are congruent because two sides are congruent. If two sides are equal, the angles opposite from those two sides are equal as well. Anyhow, we've got that, we've got this. Now this doesn't typically look like a right triangle. I don't see a right angle, but I'm about to. Find the height of the triangle. Well, when we're looking for the height of this triangle, typically we're going to draw a perpendicular line from the vertex to the base. You know that line isn't perpendicular, but y'all pretend. Alright, so if we take out our right triangle, and you get yourself a straight edge and draw yours really nicely, since I can't. So we got this right angle right here. With this isosceles triangle, this height cuts our base in half. So that means that this side is 7, and so is that side over there. It's very convenient dealing with an isosceles triangle. So this side's 7, this angle right here is 37, and what we're looking for is this height, the height of the triangle. Now, how do you know you don't want to, go to that side? Well, I don't know the length of this side. I don't know if it's 14. I don't know what that side is. I draw my perpendicular line to the side that I know, because I know it's going to split it directly in half. That's the good thing. When I use this angle up here and I come straight down, it splits this base in half. And that's good to know about an isosceles triangle. If you didn't know that, then doing this problem might be difficult. But now you know. So we're going to do, we got this angle, we got the side opposite. Well, we don't. We're looking for the side opposite, but we have the adjacent side. We don't have the hypotenuse, so we shouldn't use sine or cosine. We should use the tangent. The tangent of 37 degrees is going to equal x over 7. And now if you notice, we're going to multiply both sides by 7, because that's the easiest way to handle it. And you end up with 7 times the tan of 37. You also could put a 1 under it like we just did in number 1. And then cross multiply and get the same answer. Either way works for me. Alright, so into our calculator we press 7 times the tan of 37 degrees. And I end up with 5.3 feet. Or you could put a few more places if you wanted to, but I just want one place after the decimal, just to keep it simple. Let's try one more word problem before we're done. It's always about a guy wire. A transmitter tower is supported by guy wires that run from the tower's top to the ground. Each wire makes an angle of 67 degrees with the ground and is 423 feet long. How far from the base of the tower is each wire anchored? And I know that you drive along the road just like me, and you see these transmitter towers all over the place. I don't know if you can see them, but they're little guy wires right here. I don't think they really need to support these towers, but I do think that they need to be there, because it's all about transistors, and they help us keep our lights on, and I love them. So yeah, so keep in mind that when we solve these problems, it's all a right triangle. Let me do my sad rendition of what this looks like. You see it. Here I come. Alright, so we've got those transistor towers. So sorry, here I go, trying to make mine look like one. And they're kind of metal structures, and they've got all this good stuff going. They go all the way down to the ground. Anyway, at the top of this tower, you got a guy wire, and it goes to the ground. And they're all over the place going to the ground, and then they make like a right triangle with, one of their sides at least. Let me try to get rid of the stuff I drew so it'll look more like a right triangle. Boom, 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 boom. Anyhow, a transmitter tower is supported and each wire makes a 67-degree angle with the ground. So this is the ground. And this is my wire, so it makes a 67-degree angle with the ground. It's fully grounded. The wire itself is 423 feet long. And we want to know how far is the wire from the base of the tower. And this is the base of the tower, so we want to know this distance from here to there. How long is it? Okay, so we've got the angle and we want to find the side adjacent to it, and we happen to have the hypotenuse. So the best trig function here is the cosine. So we do the cosine of 67 degrees is equal to x over 423. I bet you can figure out what we do. We're going to multiply both sides by 423 and punch it into our handy dandy calculator and get our answer. So 423 times the cosine of 67, and we're done. It's 165.3, I think. 165.3 feet from the base of the tower. And that is 165.3 feet. Good luck.